Hi, everybody. I want to work through an insurance example problem because this can be a little bit confusing the first time you see it, and it can be really helpful to just see it walk through kind of in detail. So I'm going to share an insurance problem and point out some of the ways that you can answer questions about how much care people consume, etc. So let me get moving here. All right, so here's the scenario. We're looking in this case to calculate some consumption and other things under insurance. So let's say we have someone named Alice, and Alice's health plan provides her with the following insurance. She's got a deductible of $1,500, and the co-insurance that she faces after that deductible is 30%. Now remember, a deductible just means that the insurance company isn't going to chip in until you've paid that amount. So they're kind of off the hook for that. And then once you reach that deductible, once you've spent $1,500 of your own money, then the co-insurance rate that you pay means that whatever costs get incurred, whatever costs you incur, you are only responsible for this percentage of them. And in this case, Alice would only be responsible for 30%. So Alice is only going to use medical care if she gets sick, and she gets sick with a 20% probability. We can model her demand for her care when sick by her demand curve, which here is going to be Q equals 1000 minus 20p. And just for convenience, we're going to say that the market price for healthcare is $10 per unit. $10 is seems pretty cheap to me, but it is convenient for this example. So there are a number of things that, just based on the information from the previous screen, with a little bit of due diligence, we can figure out an actuarially fair premium. We can calculate how much Alice consumes when she's uninsured or when she's insured. We can calculate her consumer surplus, and we can calculate the price that she faces at different stages of her insurance plan. When I was in high school, my teacher, Mr. Gorehouse, always said, when you don't know what to do, draw a picture. And I drew a lot of pictures when I was in calculus. So I found this to be very helpful, and I definitely recommend that you start by drawing a picture. So put the axes and the demand curve in there, and then add the market price. So we know that Alice's demand curve is given by Q equals 1000 minus 20p. And it's very easy to plot that on a supply and demand curve just by plotting the intersections. So plunk in 0 into that equation for Q, and then you have 0 equals 1000 minus 20p. From that, you can conclude that when Q equals 0, P equals 50, and then you switch it around and put 0 in for 20. So when when you put 0 in for P. So when P equals 0, then you've got Q equals 1000 minus 0, or Q equals 1000. So you plot those points on your PQ axes, and you are off to the races. We are just given the information, there's no calculation involved, that the market price, or PM here, is $10 per unit of medical care. So we can just plot that in as a flat curve, because that is it doesn't vary with the quantity, and that is helpful for that's a little bit more simplistic, but it's much nicer to work through an example that way. And once you've got that in there, it looks an awful lot like a regular supply and demand curve graph, which is exactly what it is. So you can calculate how much care Alice will consume based on where they intersect. So take a look at where these curves intersect. Now, they're not really curves; they're pretty straight, but they intersect at this. You plunk in $10 for P, so Q equals 1000 minus 20p. Spell that out, it becomes Q equals 1000 minus 20 times 10, or Q equals 800. So now you could say, if Alice gets sick when she's uninsured, you know that she would consume 800 units of care, because that's the point, as we've done many times, we find that this is the precise point where anything beyond that care would cost $10, but it would be worth less than $10 to Alice. And any point before here, she values that care at more than $10, so she will certainly be willing to pay at least 10, all the way up until the point where they intersect. And in this case, that's 800. Now you just add in some relevant insurance stuff. So we know that the deductible is 1,500. Let's start with the deductible because that's where everybody starts with their health spending when it comes to their insurance plan. So that's a good place for us to start on this graph too. So the deductible is 1,500, and before reaching this deductible, Alice is really on her own. It's like she's in the market without any insurance at all because her insurance company isn't helping her. So how much care would she consume before reaching the deductible? This is actually just a mechanical calculation rather than like a question related to the demand curve. This is just a matter of figuring out how many units of care do you get for 1,500 bucks. So you use the market price here. You've got a $10 unit, $10 price per unit, and a deductible of 1,500. So that translates to 150 units of care. So once she's gotten 150 units of care, she has spent her deductible of $1,500. And I added a little rectangle here to indicate that. That's the sort of the total deductible spending there along the Q-axis. Now, once she's spent her deductible, then her co-insurance kicks in. So she's responsible for 30% of costs after she hits her deductible, or after she's, in this case, reached 150 units of medical care. So how much will she pay per unit of care after reaching her deductible? Prior to the deductible, she was just out there in the marketplace with no insurance, paying a price of PM. And now that we know she's going to be responsible for 30%, so she'll be paying 30% of PM. And since 10 is such an easy number, she'll be paying $3 per unit of care after she meets her deductible. So we can answer lots of other questions now that we know all this. So how much care will she consume if she gets sick while insured? That is an important one. So we know that her demand curve intersects with the P co-insured, where you can plunk this into the equation, but I just want to point this out on the graph first. So here's her demand curve. And now that she's passed her deductible, the market price, or the PM, isn't really relevant anymore because she doesn't pay it. So she pays along this $3 graph and this $3 line instead. And so she will consume the amount of care out to the point where P co-insured, this red line, intersects with her demand curve. So we can use the price when she's facing co-insurance in the demand curve. So we can put Q equals 1,000 minus 20P, which is just like what we did before when we were calculating her quantity demanded when uninsured. And now instead of P of 10, we have a P of 3. She's facing an effective price of 3. And so 1,000 minus 60 is 940. So this should be somewhat, the fact that this is a larger number, 940, is larger than the amount that she consumed when uninsured, 800. That should be fairly intuitive. When you have insurance, you consume more care. There's that's pretty intuitive. It's pretty intuitive, and so you know that if you are doing a problem like this and you find that the amount that they consume when insured is smaller than when uninsured, you know that you've probably made an error somewhere. So this is just a useful kind of face validity check. Another question that you can answer now that you've got this this nice picture is, what is the actuarially fair premium for Alice? So remember that the AFP is the expected loss to the insurer, not the total cost or not the total loss associated with the cost of medical care. It's just from the insurance point of view. So like put on your evil insurance company hat and ignore any costs that occur for Alice only, and just focus on what what's coming out of your pocket, the insurance company's pocket. So there are two states in the world here, a healthy state and then a sick state, or a lucky and unlucky, if you prefer. And the cost to the insurer in the healthy state is one part of this calculation, and then the cost to the insurer in the sick state is the other part of the calculation. So the cost of the insurer in the healthy state is very easy. Alice doesn't consume any medical care when she's healthy, and therefore there are no costs to Alice, no cost to the insurer. So the cost of the insurer in the healthy state is 0. Cost to the insurer in the sick state is a little bit more complicated. We'll work through that here. So the first thing you want to know is what are the insurer's costs while Alice was reaching her deductible? Well, we know that we went through this already, and we know that the insurance company had no costs when Alice was reaching her deductible. Their obligations did not kick in until she had met that 1,500. So the first 150 units of care, the cost there was free. They didn't pay anything. But after reaching the deductible, the insurance company finally does have some costs in the form of coinsurance. So Alice's coinsurance was 30%. That means that the insurer was on the hook for 70% of costs that occur after that. So at the 151st unit, they finally start to pick up part of the tab. And they continue to do so all the way up until Alice stops consuming care. And we calculated the quantity at which Alice stops consuming care, and that was 940. So they are on the hook for 790 units worth of care for the coinsurance cost of those 790 units. So what did each of those units cost the insurer? Well, we know that the total cost for each unit is $10. That's the market price. We know that Alice faced this curve of $3, so she picked up $3. So we know that the insurance company is picking up the difference. For this insurance company, it's $7 per unit of care. So $7 for each of these 790 units. So again, the AFP is this weighted average, probability healthy times expected cost, probability sick times expected cost. So we were given way back at the beginning that Alice is healthy 80% of the time and is sick 20% of the time. So we know that the cost when healthy is 0. And we just calculated the costs when sick. She consumes 790 units worth of care that the insurer is on the hook for. They're on the hook for $7 out of that 10 because Alice is still picking up 30% of the tab. And once you run this whole calculation through, you wind up with an AFP of $1,106. So I hope this was helpful.